My students, we are back. Now we are on the fifth parameter, and that we are calling it the expression for the range. We had already seen that earlier in the introduction. We say that the range, it is this distance from the initial t is equal to 0, and then at a certain point maybe t is equal to t. So now we want to get now the expression for the range. One, we have the two ranges. First range, we have the horizontal range, which we can denote it as R, and then two, we have the vertical range, which we can denote as H. Now, if we start with number one, that is horizontal range, which we denote it as R. So this is from that point to that point, that distance is what we call the horizontal range. So we shall call it as the horizontal distance traveled by a projectile. Is the distance or the horizontal distance taken by a projectile, and it is denoted by R. So from what we know, if we want now to get it, we know that obviously this distance, it will come from the horizontal displacement. It will come from horizontal displacement, comes from horizontal displacement. But we had already seen it, it is x, and we say that our x is equal to v naught cos theta, then times the time. But this one happened, this horizontal displacement happened at any point. It would have been here, there, or there. But now, if we reach at this point here, now it means now our x will be equal to R. R becomes the range. So at that point, our x we press there, R, is equal to v naught cos theta. But now this small t will come to be a capital T, because we had already seen if the particle is moving up to that point, t becomes a capital T. But we had already seen earlier that a capital T is 2v naught sine theta divided by g. So which is our R, we substitute it there, v naught cos theta, then it times t. We had already seen it, that is the time of flight, which is the same as 2v naught sine theta divided by g. So our R will be the same as this, we get to this and that, we get v naught squared, this and that, we get sine theta, then cos theta, then divided by h. So if you remember in the double formulas in mathematics, you realize that this sine theta and that, and this one will just become R is equal to sine, will be just v naught squared is equal to sine 2 theta divided by g. This is what we call the horizontal range. Now, before we go maybe to a vertical range, let me first get now the expression for the maximum horizontal range. Let me first get the expression expression for the horizontal maximum range, which we shall denote it as R max. Now, we from R, which is equal to V naught squared sine 2 theta divided by G. Now we need the maximum. So now, if it is a maximum, then it means that sine 2 theta will be equated to 1 at this R when is equal to R maximum. So we substitute them there. So this one becomes R max is equal to V naught squared, but this is 1 then divided by G. So that is the expression for the maximum range. The maximum range. So from that point, now we can look at the vertical range, which is the same as the maximum height. So the expression for the vertical range, which is the same as the maximum height. Which is the same as H maximum. Also, we shall sketch our projectile motion. This is, we know this is a V naught sine theta. This is V naught cos theta from what we have been saying. And then this is our V naught. This is our y-axis. This is our x-axis. So now, if we want now the vertical range, now it means it is the same as the maximum height, which is h that. So it means that our maximum height is h, at that point reach the maximum. And when the particle moves and reaches the maximum, now it means now our Vy is equal to 0, because it will no longer be moving upwards. Now, from that point, then we shall use the third equation of motion, which states that V squared is equal to U squared plus 2AS. So our V squared Y, but this is initial, are we together? Now our initial, it will be this one because it is moving up, which is V naught sine squared theta. Then this one becomes a negative G. A is equal to a negative G. Press it there, which is a minus 2G. Now this displacement S, it is going to be our H maximum, which we are looking for. But remember, at this point we had already seen that Vy is 0. So now this is 0 is equal to V naught sine squared theta, then minus 2G H max. So take this one this side, then we obtain 2G H max is equal to V naught sine squared theta. Make Hm the subject, divide by 2G divided by 2G, meaning that our Hm is equal to V naught sine squared theta, then divide by 2G. But remember, this was a square, this is a square, this is a square, and that is a square because of that square. So that is what we call the maximum height, the distance moved to reach the maximum height, and it is the same as the vertical range. So now, the vertical range, we have seen its definition is defined as the distance taken by a particle to reach the maximum point. Definition of the maximum height is the distance taken by the particle to reach the maximum height. My students, thank you for attending. We shall meet next time. Thank you.